Start recording. There we go. Now, this particular device here, if you hadn't yet worked with one, it represents the beams on one of these doodads, which is a balance. And the reason it's called a balance is because you slide these little doodads along and they balance whatever is on the weighing pan. Okay? So if you're looking for what this measuring device is called, it is called a balance. And you'll notice I've written that far over on the right, and that is because it is a specific type of balance. And you'll notice it's got 1, 2, 3 little reedy things. And that means it has 3 beams, which means it is a triple beam balance. The balances that we have in the classroom have 4 beams, and therefore they are quadruple beam balances, all right? And they will actually go to 1 more decimal place than this, make-believe triple beam balance. So if we look at this, just to make sure you all understand how to read them, all you do is you take the numbers and you kind of add them all up. We have 500. So we're going to write down 500, and I'm going to write it over here, okay? 570, so 570, and then it's somewhere after 577, so I'm going to write 577 point, and then we got to zoom in a little so we can see it better. 577, this is 7.5, this is 7.6, and this is 7.7, and we are in between 7.6 and 7.7. So we're going to be 577.6, and then you get to guess at that final digit. Yes? So that could be a 6, it could be a 5, it could be a 7, whatever you like. Yes? How do we like that? How many points would I score on the quiz for that answer? 1 out of how much? 3. What am I missing that would give me my full credit? I am missing, first of all, my units. That's really easy, okay? And if you're looking for units, it's usually written on the measuring device. And the second thing we are missing is what we are measuring. Let's go look back at the beginning of the question, and it says we are measuring some salt solution in a beaker. And because we're using a balance, we must be measuring the mass. Okay? It's all good, don't worry. That's why we're learning it, right? We're measuring the mass. Okay, so the mass of the beaker plus the salt solution. And I've just abbreviated solution like that because it made it fit, which is always a good thing. We have 5 sig figs in that number, and you would now get your full 3-point credit for that. All right, so that is, we were measuring a beaker with some salt solution in it. So that's question 1. Question 2, we were measuring an empty beaker, but it's the same beaker as in question 1. So in question 2, we are measuring an empty beaker. So it should weigh, hopefully, less than 577.67 grams. So let's see what it actually does way. Again, what's this device called? This is a triple beam balance. And we have 498 point something. So that's 498.9, maybe 0.99 or 0.98. Okay, because we're really close to the next digit. Okay, so 0.98 grams. How are we feeling about my answer there? No, I'm seeing some shaking of heads. Why? What have I forgotten? Mass of, unfortunately, it's a smaller one this time, so I can cram it in right there. Mass of beaker equals. All right, we've got 5 sig figs. Now, on the quiz, there will be a subtraction kind of question. It might be one like this, or it might be one like where you had the burette and you measured the initial volume and the final volume and found the difference to find the volume delivered. Okay. When you are doing that, you will get 1 mark for the word equation. So if I'm looking to find the mass of the salt solution alone, I'm going to take my original measurement, which was the salt solution and the beaker. So that's the mass of the salt solution plus the beaker. And I'm going to subtract the mass of the empty beaker. That's the mass of the beaker. Okay, so you get 1 mark for writing it out in words. And then you get 1 mark for plugging in the numbers with the units. Okay, so that's going to be our original number, which was 577.67. And my unit goes there, grams, minus 498.98 grams. And if I do that subtraction, 577.67 minus 498.98 equals 78.69 grams. Is good? Okay. If we looked at all of our uncertain digits, they are all in what position? They are all in the 0.01 position or the 100ths position. And for anyone who has done sig figs in physics, and you're like, hey, I started with 5 sig figs and 5 sig figs, but I only finished with 4 sig figs, what is up with that? There is a different rule for adding and subtracting than there is for multiplying and dividing. We will all be learning about that in the next unit. For this unit, don't worry about it, just do the subtraction and leave it as it is. Is good? Okay. So we started with 5 sig figs and 5 sig figs, but in our answer, we only had 4 sig figs, and that's okay because that's how subtraction works. Okay? Any questions on anything to do with measurement for your quiz? Okay, we're going to learn the very last thing, the very last sort of theoretical thing before our test next week. The rest of the week we will be finishing up labs and things like that. Wednesday we'll do a lab. We will have a quiz on the algebra and units on Thursday, and we're going to combine that with the thing we're learning next, which is 1.5c, page 100. Number. Exact and inexact numbers. So, exact numbers are not measured. Everything we've done up till this point with sig figs has assumed that we have a measurement. But if something is exact, it is not measured. There is no estimation, there's no approximation, nothing. Okay? So if I hold up these pens and I say to you, how many pens do I have in my hand? 2. Is that approximately 2 or is that exactly 2? That's exactly 2. It's not 2 plus or minus 1 pen. It's not like, oh, maybe there's only 1 or maybe there's 3. Who knows? It's not been approximated. You know there's exactly 2. Okay? And what that means is that there's no uncertainty here. None, no uncertainty. We could say I have 2.00000. I could write zeros from now till infinity, and it would still be true because there's no fractional pens in my hand. Yes? So exact numbers are not measured, and one thing that may not be measured is if we count things. Okay, 4 eggs, 8 molecules, 17 elephants, 35 atoms. Those are all counted. And if we have counted and if it is exact, then we have infinite sig figs. Okay? Now, we can count things, but when the number gets big enough, you might have to assume we have made an approximation. Okay? So if I write down 4.3 times 10 to the 6 atoms, if we take that out of scientific notation, all of a sudden it looks like that. Yes? Does that seem reasonable that we counted all 4,300,000 particles and exactly that number? No, we are probably approximating that number, and so this number would have 2 sig figs because it is approximated. So smaller numbers that you could actually count, 35 atoms, those will have infinite sig figs. Large numbers, where it looks like it's probably been rounded off at some point, those will have however many sig figs are in the number. Okay. Definitions. So you can have a number that is exact because you have counted it. You can also have a number that is exact because it is defined that way. So, for example, 1 inch is defined as exactly 2.54 centimeters. That is an official definition that the International Union of Chemists and Physicists or something like that has come up with. The only way you would know that that number is exact is because I have actually written the word exactly. Okay? Is there any way that you would know that otherwise? unless you know, have studied chemistry for as long as me and you just know that, okay? However, there are some things that you just do know and you will know that they are exact. For example, 60 seconds equals 1 minute. Are either of those approximate? No. 1 minute is not going to be equal to 61 seconds today and 59 seconds tomorrow. It will be equal to exactly 60 seconds. 24 hours in a day, are either of those approximate? No. Okay, so all of these are exact. 100 centimeters in 1 meter. Are there about 100 centimeters in here, or are there exactly 100 centimeters? Exactly, okay? So those are definitions, and all of these numbers are exact. A centimeter is defined as being exactly 1/100th of a meter. If they are exact, how many sig figs do they have? Yes. Infinite sig figs, yes. Now we're going to get into some approximations, okay? And these are some inexact numbers. And these are some equalities, which means that the thing on the left is equal to the thing on the right, okay? So I might actually write that 1 mile is equal to 1.6 kilometers. If I was, say, swimming or something and I wanted to do a quick conversion, maybe even in my head if I was very brave, I could use that conversion factor because 1.6 is a fairly small number. It doesn't have too many digits. I might be able to do that in my head or just with a piece of paper. Yes? However, I could also write that conversion factor as 1 mile equals 1.6093 kilometers, and that would be a more precise equality. However, even that is not the true measurement, the true definition, because 1 mile is actually defined as 1.609344 kilometers. Okay. Again, that's one of those things as exactly 1.609344 kilometers. Now, if I wanted to do the conversion in my head from miles to kilometers, do you think I would like to use 1.609344? Probably not. That sounds horrible. Even if I was typing it in my calculator, there's a lot of room for like hitting the wrong button. Yes? It's a lot of buttons to hit. And so I would probably use a much simpler version of that equality. So if we have it defined as exactly 1.609344 kilometers, that means that this number is exact. How many sig figs does it have? If it is exact, it has infinite sig figs. Okay? That's because somebody somewhere in the International union of people who make measurements and define things, they said 1 mile is exactly 1.6 times 1.60933409344 kilometers. But if I write 1 mile is equal to 1.6 kilometers, is that wrong? Or is it just not exact? It's not wrong, it's just rounded off. It is just not as exact. So this number has been rounded off. So now it is not exact. And if it is not exact, how many sig figs do we have? 2 sig figs. How about 1 mile is equal to 1.603 kilometers? Is that exact? This one over here. Is that an exact number? No, not exact. It's been rounded off. And if it's been rounded off, it's not exact. So how many sig figs does that have? 5 sig figs. So we spent a lot of time talking about that number for the kilometers. What about the number for the miles? We have 1 mile, 1 mile, 1 mile. Is that number exact or is it inexact? If it's inexact, it has some uncertainty in it. Chat with your partner. See what you think. Do you think that mile is exact or do you think it's inexact? 1 mile. If it were inexact, it would have a countable number of sig figs. If it was inexact, how many sig figs would there be in 1 mile? If it was inexact, if it was not exact. 1 mile. 1. It would have 1 sig fig, which would mean if we had 1 mile, which was not exact, that would mean that we would have 1 mile plus or minus, because that's our uncertain digit, right? 1 mile, which means that our number could be as high as 2 miles or as low as 0 miles. Is that what we are saying? Are we saying that 1 mile equals 1.6 kilometers? Well, maybe it's 0 miles equals 1.6 kilometers. Are we saying maybe it's 2 miles equals 1.6 kilometers? Is that what we're saying? No, we are saying 1 mile. 1 mile, not 2 miles, not 0 miles. 1 mile is 1.6 kilometers. So that number there is exact. And because it is exact, how many sig figs does it have? Infinite sig figs. Now, we could take a look and we could say, okay, I'm actually going to go over to the ones on the right-hand side because there's a little bit more room over there right now. So I have 1 meter, I have 1 ounce, I have 1 quart, I have 1 gallon, okay? And then I also have 1.0936 yards, 28.35 grams, 0.94, 635 liters, and 3.7854 liters. Which of those numbers are exact and which are inexact? All the which ones? The red are inexact, yes? Okay, so all of these ones here, these are all inexact. All the blue ones, 1 meter, 1 ounce, 1 quart, those are all exact. So here we would have 5 sig figs, 4 sig figs, 5 sig figs, 5 sig figs, but all the ones on the right would have infinite sig figs. Infinite sig figs. Infinite sig figs. Infinite sig figs. Which of those units are metric units, SI type units? Take a look through those numbers either in the blue boxes or red boxes on the right and determine, talk with your partner, which of those are SI units, metric units? Okay, so which ones are metric? Is meters metric? Yes. Is yards metric? No. Is ounces metric? No. How about grams? Yes. Quarts? No. Liters? Yes. Gallons? No. Liters? Yes. So what you'll notice that on each side of these equals, of these equalities, you have a metric measurement on one side and you have something else on the other side. It's like the American measurements. They call them imperial measurements. So these are all equalities between metric and imperial measurements. So when you have two different measuring systems, let's say metric and imperial, all the equalities, they'll all have like a 1, right? And then they'll have a number with a decimal. The 1 will always be exact. The number with the decimal will be inexact. The thing is that imperial and metric don't convert nicely with each other because they were made up at different times by different people. Yes? Whereas if you have a metric-metric conversion, 100 centimeters in 1 meter, is that a nice exact conversion? Yes, there are exactly 100 centimeters in 1 meter. If instead of a meter stick, I had a yard stick, which is just slightly shorter, and a yard, which is about this long, is 3 feet long, 1, 2, 3, is that approximately 3 or exactly 3? That's exactly 3, because the people who did the imperial measurement system said 1 yard is 3 feet. Yes? So on our next page, what you'll see is that if you have conversions within one measuring system, like imperial, both the numbers in that equality will be exact. And the nice thing is that they kind of look like they should be exact too. Like 1 foot equals 12 inches. Doesn't that kind of look like it should be exact? As opposed to 1 kilogram equals 2.2046 pounds. Does that look like it should be exact? Probably not, right? 1 yard equals 3 feet. Those look like nice, tidy numbers that someone defined 1 yard as being 3 feet. Yes, somebody defined a foot as being 12 inches. So those are defined quantities within a particular measurement system. Just like if you have 1 meter equals 100 centimeters, that is, both those numbers are exact. That is exact. That is exact. They both have infinite sig figs. But going back to conversions between the imperial and the metric, and how are you going to know it's imperial? Because it's not one of your liters, meters, moles, and Kelvin, kilograms, and seconds. Yes? Mm-hmm. So you look at this and you're like, pounds. Pounds is not in my song. Therefore, that must be that other weird measurement system that doesn't make any sense, but Americans still use it, and often Canadians do too, because we sort of never got around to converting completely. Canadians are really weird because we use metric for so many things, but then it's like if I ask you if you're Canadian and I ask you your weight, you will probably give it to me in pounds. We use meters for measuring distance and height and all sorts of things. But if I ask you your height, you'll probably give it to me in feet and inches if you are Canadian and you grew up here, because it's just weird that way. We use Celsius for the temperature outside, but our oven measures temperature in Fahrenheit. I think it's just because we have that big neighbor to the south, and a lot of the things, a lot of products are carried over from the US, and so ovens and stoves and stuff just have the same thermometer. Anyway, yeah, the only time that these are not inexact is if I write the word exactly. If I write the word exactly, then that number is, guess what? If the word exactly is written, the number is exact. Yes, okay? That's a pretty good giveaway on that one. Yeah. constants are not exact. So you may come across some constants like, if you did physics, H is equal to 6.626, and I forget what the unit is. Anyway, whatever. We will be using the constant 6.02 times 10 to the 23 particles per mole. And if you recall, a mole is a measures amount of matter. So a mole is a number. If I were to say to you 1 dozen, what number does that mean? It means 12. 1 dozen equals 12 things, whatever those things are. Okay? If I say to you 1 mole isn't equal to a nice number like 12. It's equal to this gargantuan, huge number, 6.02 times 10 to the 23 things. Do you think that is a counted number, or do you think that is an approximated number? Counted or approximate? Approximate, okay? So when we get into the mole unit, you'll be using that and you'll know that, oh my gosh, that's a huge number, it must be approximated. And in fact, if you were taking AP chemistry, we would actually give you an extra digit on there, 6.022 times 10 to the 23. And in actual fact, they have calculated the mole to more decimal places, 6.022140876 times 10 to the 23, but even that is probably an approximation. So yeah, anyway, there we go. I'm going to get you to do pages 102 to 103. Those are on exact and inexact numbers. This is equipment B. Start halfway down, page 16. Some of you may have done this already, okay? And we will have time tomorrow in class if you don't finish it today. Okay, this is equipment B. And then we have extra practice making measurements, which is 1.4E and 1.4F. And that's what you might want to work on in order to be prepared for your quiz tomorrow. Okay? There will also be a quiz Thursday on algebra and on this exact and inexact stuff. Okay, so like the stuff we did on Friday and the stuff we did today. And I will be handing back your quizzes while you get started on that. Done. Caitlin. Michelle. Ah, can't get them apart. What is wrong with me? There we go. China. Cocolin. Diane. Bella. Isaiah. Nathan. Austin. Kira. Jonathan. Atrin. Gustavo. Andrew Ha. Do I have 2 Andrews in this class? I can never remember. Matthew, Cade, Archer. You're getting Archers? Okay. And Alex. There you go. I have 2 more versions of that if you want to retake it at some point. I also have a little extra practice. Let me know if you would like that. Oh, and Wesley, I have yours. Sorry. Would anyone like a little extra practice sheet on scientific notation? Totally optional. The answers are not on here yet. I have to make the answers. Anyone else for an extra practice? Good stuff. I take it you're retaking the quiz? There you go. You want to? Okay. Yes. 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 I'm going to turn this off so it doesn't blind people up. Yes. One point likes the answer key fit on a page, so I just put it on that at the end. Sorry. Every once in a while, there's one that just fits, and so I just chuck it in there. Maybe I'll have to reconsider that. Oh, and then say refer to, yes. Yeah. Getting home? Yeah. That's okay. Racing's good. Doesn't matter which one you take. They're all the same. Yep.